Welcome, ladies and gentlemen, to 18.3, which is I've entitled Ray Tracing with Lenses. So it's going to be a lot like the ray tracing we did with mirrors, where you ended up drawing the principal axis, the principal plane. Ray 1 comes in, Ray 2 goes to the center, and then what happens? So the purpose of today's lecture is to answer the question, when you look into a lens, what sort of image are you seeing here? Like, this is an image that I grabbed off the internet. I think this is like a drop of water or a glass ball or something that's out, and you're looking through it and you see that it's upside down. Like in the picture we have, it's right side up, but when you look at the background, it's upside down. Wine glass. Water is considered a lens. It has a different index of refraction of air. Here's a picture of a drop being flung up, and there's a globe being shown behind it. Dew on blades of grass, and here's a wasp. This one's kind of fun. There's a wasp that's using surface tension on the water, but when the water looks invisible, but down here you see some sort of like what's going on there. And this is a glass of water in front of a diagonal background. So we're going to answer the question, how do you know what the image looks like? Is it going to be a virtual image? Is it going to be a real image? Is it going to be enlarged? Is it going to be smaller? Is it going to be upright? Is it going to be upside down? We're going to answer all of these questions today. The first thing I want to talk about is types of lenses. There's two main families of lenses here. And family number one is convex lenses. All of these here are considered convex. Family number two, these are all considered concave. On your test, you'll be given a lens, and you have to identify what type of lens it is. Now, the first two of each family are pretty easy. This one right here is a double convex, pretty easy. Both sides are vexing out. This one here is plano, so it's a flat plane, convex. Over here with this family, the double concave, the plano concave, and here's where they get crazy. These ones right here are a little bit tricky to know which ones they are. Couple clues you can use. Number one, look at all of these lenses. They're always fatter in the middle. So if a lens is fat in the middle and skinny on the edge, it's always convex. So this one's concavo-convex. If you get over here, if it's skinny in the middle and fat on the edges, this is concave. So this one's convexo-concave. Eyeglasses are always this type of lens or this type of lens. And you can tell just by looking through it. Like when you look through right now and look at my eyes, I know this is a convexo-concave because it makes my eyes smaller. Like when I pull this away, totally makes my eyes look smaller. If it made my eyes look larger, it would be a convex lens. So they're different for nearsighted versus farsighted people. So there's thing number one, knowing how to identify your lenses. Thing number two, what do these lenses do to light? If you've got a convex lens, what it does is it focuses the rays. You can see these being focused to the focal point right here. This is the focal point. And over here, with a concave lens, these are a diverging lens. They spread them away. And if you were to trace these backwards, there's a focal point here. Now, the focal point in this case, since it's a virtual focus, the focal point for a concave lens is negative. The focal point for a convex lens is positive. And it's funny, it's the exact opposite for mirrors. A concave mirror has a positive focus, and a convex mirror has a negative focus. So they're just a little bit different. We're going to talk about the ray tracings, just like what we did before. So what I've got, let me see, 1, 2, 3, 4, 5 scenarios set up with a convex lens. And then I've got the same thing set up with a concave lens. And I think I started out, my object is really close. So it's really close. It's before the focus. And then I put it on the focus. And then I put it behind the focus. And then I put it on the center. And then I put it past the center. So I've got those scenarios here. And I do the exact same thing with concave lens. Now, to get us started, the first thing you need to do, if it's not already done for you, you have to draw the principal plane, then you have the principal axis, and you have to draw the principal plane. If those aren't done, you need to do those. So, when we draw these, remember you have to use straight lines, and ray 1 goes right to the principal plane. It's going to go through the lens, through the focus. Just like this picture back here, the ray comes in and goes into the focus. Ray number 2 is going to go right through the center. So here's our scenario. These are diverging, and you have to trace them backwards. So you're going to have to trace them back to see where they cross, and they look like they cross right here. And here is where my image is. So this is how a magnifying glass works. It's a virtual, larger, and upright image. Virtual, meaning that the distance to my image is going to be negative. Larger, the height of my image is going to be bigger than the height of my object. Upright, the height of my image is going to be positive. So these are things you can tell, just like with our mirrors. Let's go on to our next example here. Here we've got one where we're on the focus. If you remember back to the mirror scenario, this one gave us no image. And let's see if we get the same thing here. And you'll notice these are parallel. If I trace them backwards, I am going to get, again, no image. So here, just like in last time, no image. Over this, our next one, ray 1 goes into the principal plane. Ray 2 goes down through the focal point. This one here, these are going to actually cross now. I'll extend this guy out. So these guys look like they're going to cross over here. So I have a huge image. So it's very large, it's inverted, and it's a real image. So the distance to my image is going to be positive in this case. Go to my next scenario. Ray 1 comes into the principal plane, down through the focus. Ray 2, right through the center. So here's my object, or my image right here. A real image that's inverted. So the height of my image is going to be negative. The distance to my image is going to be positive. And here, in, through the focus, through the middle. So what can we conclude? The farther away this gets, I think the smaller that's going to get. The farther away my object gets from the principal plane, the smaller it's going to get. How do I get a larger image? Well, how do I get a smaller image? How do I get a real image? How do I get a virtual image? These are all questions that are good test questions that it takes looking at all of these and making generalizations that I'll leave to you. The next scenario, doing concave lenses. Concave lenses are just like convex lenses, except they're different. Ray 1 comes in, that's the same. How it's different, instead of it going down to the focus, it's going to go away from the focus, just like this scenario here. It comes in and it goes away from the focal point. So then I grab, it's going to go away from my focal point. This one goes like this. So when I trace this backwards, here is my image. Smaller, it's going to be positive. The distance to my image, it's going to be negative because it's virtual. Again, ray 1 comes in, it goes away from the focus. Ray 2, right through the center. I trace this guy backwards. There's my image. Same thing. I wonder if the next one's going to be this way. It looks like it's kind of shaping up like that. Ray 1, away from the focus. Ray 2, through the center. Well, this looks just like the convex lenses or mirrors where everything is always going to be right side up and it's always going to be smaller. And that's what you see when you look through my glasses. When I look through here, no matter how far away, it's always going to be smaller. And you can tell how bad someone's eyesight is by how small their eyes are when you look through their glasses. If their eyes look about the same size as what they are normally, you know that they don't have a very bad prescription. But if they look really small, you know those poor suckers are blind as a bat. So in every case, we get virtual images that are smaller. So this kind of concludes how we do ray tracing. It's very similar to doing the ray tracing with mirrors. It's different in the fact that the rays go through the lenses. With mirrors, they go and they bounce off, but with lenses, they travel all the way through it.